Hello, everybody. Good afternoon. Well, it's always a great pleasure for me to be here at Devoxx. I have to confess to you, it's a bit colder than I expect here in Antwerp. And just in case you're wondering, I think I told this last year, but I'm a Brazilian Japanese, and not the typical Brazilian you would expect. But yes, Brazilians can be anybody, and I get a lot of questions about that. My name is Edson Yanaga, and I'm currently a Director of Developer Experience at Red Hat. My Twitter handle is @Yanaga. And today the subject of this deep dive session is slice and dice your monolith with domain-driven design. So we're going to discuss a lot of different approaches, both for code and for architecture. And we have, I hope, enough time to be covering all of this with some live coding too. I'm also a Java champion and a Microsoft MVP, which is like a different combination, and I think that's so far unique. And many of the techniques, I'll be discussing a bit about CQRS and event sourcing in the second part of this talk. And I'll be just presenting a just one integration technique for you to create your architecture with that. But if you want to dig more into the subject, I released the book from O'Reilly, Migrating to Microservices Databases, where I discuss other approaches for creating your CQRS architectures. And on Wednesday, I'll present in a talk, because this book is only about relational databases. And after that, I've discussed it with many people, other approaches for creating these CQRS architectures, event sourcing, with different data stores and different data requirements. So on Wednesday, I'll have another talk about that, where we'll discuss different requirements for data and how can we create different CQRS architectures with that. But for relational databases, this is the reference that I have. And some of the things that I'll be discussing today are written on the book too. And I always like to start my talks with this quote from Forbes, just in case you already heard about that. I'll just be repeating in a very few minutes again. Now, every company is a software company. I like to say in all the places I visit, you don't work for a bank, you work for a software company. You don't work for an industry. You work for a software company, because software is changing the world. Some people call this digital revolution or digital economy. And I like the definition of digital economy, because I used to be one of these people that thought that economics and economy had everything to do about money. But after studying some economics, and particularly behavior economics and behavioral psychology, I just learned that economics has nothing to do about money, but has everything to do about people. Because basically they study how people interact with each other in a system, and which are the motivations that people have to change the system from one state to the other. And some motivations can be love, can be hate, can be power, and can be also money. And when we're talking about software, software is an economic system, and we're designing software for economic systems too. Because software is developed by people, for people. Every time we forget that, we don't get an optimal result. That's why it's so important for us to have the discussion about microservice architecture and domain-driven design, because in the end, it all that matters, the thing that truly matters is the people involved in developing the software and the people that are receiving the software. And some great examples of this new digital economy are that the largest car transportation company in the world owns no cars, which is Uber, and I realize that it doesn't work here yet. The largest lodging company in the world owns no real estate, which is Airbnb. The largest online retailer in the world owns no stock, which is Alibaba. And the largest content network in the world produces no content, which is Facebook. All of these companies, they have something in common, is that they only exist because of software, and the software that they are producing is changing the way that people interact with other people. That's what I like about this digital economy. We are changing the way that people interact with each other. And since we're talking about domain-driven design and how to create and craft better software, I always like to introduce myself too as a software craftsman, and I know that we have many different definitions about that. Some people like, some people don't. But for me, the best definition that I have for a software craftsman or craftswoman is somebody that, when he or she cares about the job that he or she does and the software that we deliver for the people, because we know that we can change people's lives for the better, but we also know that we can make them miserable. So we always make a choice. I made a choice 6 years ago that I didn't want to to provoke that feeling of making people miserable with the software that delivered, because sometimes we're just in a job for the money, we're just delivering, we're just coding, we really don't care about the impact that we're having with other people's lives into production. And I thought that if I wanted to keep doing what I did and what I do, like coding, I really wanted to have a bigger purpose, because in my career, I thought that it wasn't meaning anything to me at that moment. But after reading that we can all change people's lives for the better with what we do, I think that's a role, that's a purpose that I took many years ago. I think that's a decision, that's the choice that we can all make today. And I also believe that software is a craft, because it's not like an industrial thing where we can always deliver the same thing multiple times. Every time you craft a piece of software is different from the previous one. And even if we were paid to do the same software twice, we would do that differently the second time, because we would know better things, we would have more experience, we would have different techniques for applying that, we would have different technology, and we certainly could provide a better result at the second time that we do the same software. That's why I believe it's a craft. It's close. I think it's much closer to an art, in the sense that we're always trying to produce something better than in some industrial process where we're trying to just reproduce the things that we did in the past. And when I visit the Computer Science Museum at Palo Alto, this is one of the quotes that I like to put in this kind of talk, that computer programming is an art because it applies accumulated knowledge into the world, because it requires skill and ingenuity, and especially because it produces objects of beauty. I'm pretty sure that for many of us that we care about the code, very few things in the world are better than seeing like a very nice piece of well-crafted code, especially if we were able to do that. So I don't know, maybe today is a good thing, tomorrow is not such a good thing. But I think we always need to try to improve the thing that we're doing. And in the past, I always cared about the code, the quality of the code that I was producing, and in some days I just used to look at the code that I did like 2 months ago. I was looking at that, I was saying to myself, what a crappy thing. And I used to be pissed about that, but later I realized that if I today I can see the code that I created like 2 weeks ago or 2 months ago or 6 weeks ago, and if I can say today that this code is a piece of crap, is that because today I can do something better. I think that's the goal that every programmer should have, that we should take a look at our code that we did like in the past. If we look today, we need to be able to say that, well, today I can do much better than I did in the past. That's one of the nice things about our profession. And also, the last quote that I want to present to you is that from Jordan Apello. No matter what other methods you apply to achieve competence in a social system, in the end, it all depends on whether people actually care. So I believe that if you're all here at Devoxx, which for me is the premium developer conference in the world, is that we all care about what we're doing. And just in case you're watching this video on YouTube too, I believe that you care about what you're doing, and we can all craft better software to change people's lives. And since we're going to discuss about domain-driven design, the Eric Evans book, Domain-Driven Design, was written more than 10 years ago, but I still think that we're trying to catch up on the concepts and the methodologies and the things that we should be doing to have a proper domain-driven design. And if you read Eric Evans' book, I think it's a very hard read, because you get a lot of this concept. Even when I read the book in the past, I read like 2 or 3 times. You read the book and you see, oh, this is amazing, but how do I apply these concepts in practice? It's very hard to grasp. And in the past few years, we had some authors like Von Vernon. He wrote some very nice books about how to implement domain-driven design in practice. But even still, I think it's hard for most of us to be dealing with the practical aspects of trying to apply domain-driven design. And I know that if you ask any domain-driven design expert, he or she is going to tell you that, well, domain-driven design is about finding the why are you doing the piece of software that you're doing now. So you need to know the reasons, the business requirements. You need to talk about domain experts and everything else to know how the software works. So it's mainly like a design thing. That's why it's domain-driven design. But even after you decide, well, we know which kind of system we want to design. We know the requirements. We know the events that we have in your system. We know how to properly tackle the complexity of that. We have a gap still on how to apply these things in code. That's why I dedicated a good part of my life in the past few years trying to uncover better things to transform these ideas into code. And I hope to be able to share some of this to you. And if you think about after you're able to apply some domain-driven design ideas and concepts into your code, it will be much easier for you if later you decide to create a microservice architecture about that. Because people always say that the magical thing about domain-driven design is properly defining your bounded context. And if you have properly defined bounded context, it will be much easier for you to later be creating your microservice architecture, because then you can easily map each one of your bounded contexts to a different microservice. And when I thought about this session, I looked about many different source code bases available as open source in GitHub. I tried to dig through many of them, but then I realized that most of the source code that we have available to try to apply some domain-driven design and later refactor to a microservice architecture, they have such a degree of complexity that it would be almost impossible for me to show something useful in just 3 hours. It would take like weeks to be working with a team to just design properly. So even though it was my initial idea, I wasn't able to find a proper source code base, a legacy source code base to be doing that. So I had to create a simplified model just to explain some concepts to you. That's why what we're going to use today. And with that, I intend to show to you some code smells that happens in every single piece of code that I've been looking at in the past like 10 years. I used to be an independent consultant before joining Red Hat, and I used to help many different teams ranging from small startups to big like big banks and financial industries, and also large like online retailer companies. So I've seen like this kind of some of the code smells that I'm going to present to you. I've seen that a lot, and I've always been able to help people to refactor these code smells into better code. So later we can try to apply some proper domain-driven design concepts, and maybe later we can even try to split some of these concepts into microservice architecture, which is the thing that I will discuss with you in the second part of this talk. So some code smells that I think that are very important for us to tackle to be able to create a proper model. First, primitive obsession. We're just even some of the domain-driven design books that I've read in the past months, they still they try to apply domain-driven design, but they still have this code smell, this primitive obsession, because even when we're talking about aggregate entities and value objects, in many different cases, I think we're not applying custom types in the proper way. So primitive obsession is an anti-pattern or a code smell saying that if you don't know if you should be creating a custom type and your own type for defining something in your software, then maybe you should. Because it's much easier for you to remove a custom type than later try to add a custom type to your code later. And we have this nice article from Martin Fowler, When to Make a Type, which basically he describes some of the reasons for you to create a type in your software, which is basically, if you're using Java, to create a new class to represent an abstraction in your code. And I would argue that in like 90% of the times, maybe you should be creating a custom type for your domain model at least, okay? And we're going to explore that. Other things that we need to talk about. I know there's some backchatting about talking about null pointer exceptions because there's no proper solution for that. But I think that depending on the use case for that, you may choose between different solutions for your problem. Depending on the use case, we can apply null objects. Depending on the use case, we can apply Java optionals. Depending on the use case, we can try different approaches, even embracing null. In some use cases, I'm trying to discuss some of the options that we have also in our code to apply proper null handling. And talking about splitting, well, if you're going to be able to refactor your source code properly into a domain-driven design, proper aggregates, entities, and value objects, proper encapsulated code, proper encapsulated data. After I have that, how can I split this thing in proper modules and later maybe proper microservice architecture? And just to tell you what I consider to be the proper solution right now is that if we're talking about which kind of problem we're trying to tackle when we're discussing splitting our architecture into microservices, we have different scopes that we can approach. We're talking about the problem. We have simple problems, and we have complex problems. We also have easy problems, and we have difficult problems. I would say that split after we have a proper encapsulated code and data in our code base. I think that splitting that in a microservice architecture is basically should be targeted. We're much closer to the simpler problem rather than complex, but we're much also closer to the difficult part instead of being easy. And I know how many of you had distinction in mind, but I used to be confused about the distinction between simple and complex and easy and difficult. But basically, and we know that something that is simple is easy. I would say that becoming, or give you a popular thought. I would say that we all know the recipe for getting thinner, like to lose weight. Losing weight is something simple. We just in theory, we need to eat less than eat less calories than what we spend. So it's a very simple way to solve a problem. But is it that easy? Certainly not. That's why most of us have a big belly. That's my case too. So it's very difficult for us to lose weight. So now we have this kind of simple and complex, easy and difficult. I would like to say the splitting later is simple, but it's very difficult, mainly because of the data associations that we have in our code base. And I also had to learn that most of the techniques that I have to show you today is basically a process of wash, rinse, and repeat. I don't know how many of you are a native English speaker. I'm certainly not. I speak Brazilian Portuguese. And for me, I always read this rinse and repeat thing that we had, and I had to Google and I found on Wikipedia the source for that, and I just realized that it's a very sarcastic way to be saying that something should be done up to exhaustion, maybe with some recursion. And then I realized that in English, it's usually the wash, rinse, and repeat. That's the thing that they write on shampoo labels. So for you to be spending your shampoo in ad infinitum. So for me, it was a curious thing to be learning when I was preparing for the talk. And later you realize if you are able to create your microservice architecture, you have to embrace CQRS. I'm not pretty sure if everybody needs to embrace event sourcing, but definitely your architecture will embrace events. So we're going to discuss some of the motivations for you to be creating your CQRS architecture, why event sourcing is appropriate for some use cases, for others it's not, why you should be using events, and how will you be creating your CQRS architecture. I thought about a very well-designed diagram to show you what is a CQRS and event source architecture, but I think it's much easier for me to explain what is a CQRS architecture, what is event sourcing, and how can I apply that through, if I just show you code, right? Some live coding, maybe. So we're going to create some CQRS architectures, we're going to create some events, and maybe we'll be able to, depending on how much time we have, maybe we might even be able to create an event source architecture for that. But I'll stop talking with slides for now, and now I want to show you some proper code. Okay, so now let me, here, I have my console. Okay, I'll increase the font later. I have here my IDE. Okay, here I have a typical legacy application. Well, not so legacy, but I want to say that it's a monolith because basically I have an artifact for doing everything. But I want to use something novel, so it's a monolith, but I'm using Wildfly Swarm just because it was very easy for me to create a project using Wildfly Swarm. But we have like the traditional Java EE APIs, we have EJBs, we have JSF, and we're going to use JMS too. Native queries, and we're going to introduce some other cool technologies that I think that are appropriate for creating our CQRS architectures and our properly encapsulated code. So I already have a model running here into production, and just to show you, but I did I did it in the proper way. So if I need to run my monolith here, I'm gonna run floor swarm.run. And I'm just using like my CLI because now Maven has a color output, so it's very nice to see. It took us like, 15 years. At least now we have colors. If I get to run my Wildfly Swarm application, I already have some things running. And if I start it up, okay, if I open here, okay, my application is already running. Then I can just go through the codes, saying to you, oops, here. So, but I'm not interested in the part that is already running because I try to apply some domain-driven design techniques on this part. But I want to show what most people do when trying to create their domain model using traditional applications. And I'm not talking about legacy because I believe that many people are still trying to apply this concept new code being done today. So, talking about packaging, when we try to organize our code in packaging, I've seen many different ways that people try to organize their code, but most legacy code bases try to organize, and that's the thing that you used to do in the past too, try to organize their layers in the software architecture by type. So basically, if you're using DAOs or repositories, you just put all of your interfaces, implementations, repository types there. If you're using controllers for your web interface, you put all the controllers on the same package. If you're using like service, if you're creating service classes, which many people think that is a nice thing because it's a domain-driven design thing, you just put like all of your service classes in the same package. So basically, you have very few packages in your system. It's like you might have a package with I've seen like a package with like you can have like 300 classes, and each one of these classes can have like 2,000 lines. This is the traditional legacy way of applying packaging and crafting your code. We can do better with that. And so what I propose, you can use a traditional domain-driven design layered architecture. Some people try to advocate for hexagonal architecture these days, where you think that everything runs in the core, you have your domain model, and everything else is an adapter to the outer world. Like if you have a database, you have an adapter to be storing your entities into your database. If you're exposing your data through REST endpoints, maybe you have an adapter to be exporting that. If you're using some kind of messaging system to expose your data, maybe you have an adapter for that. I think that's a very nice way for you to organize, but that's not the approach that we have available when we're talking about legacy systems. And usually we'll have a traditional layered architecture. And I think that after you are able to think about which are your proper bounded contexts, and one tip that I give to many different teams, well, what is this bounded context? How do I find the bounded context in my system? I think that the easiest way for you to find your bounded context in the system if you try to apply the transactions boundaries that you need in your domain model into your source code. Because in very, very rare situations, you need the transaction to be spanning between different bounded contexts. So if you're able to find like a single piece of your source code where all of the transactions that are applied in your source code base that are contained in the same domain model, I think that's a good candidate for a bounded context. Okay, so you will rarely see transaction boundaries being spanned across different bounded contexts. So creating a one-to-one relation between transaction boundaries and domain model is a proper way for you to identify a bounded context. But again, bounded contexts are a modeling problem. Okay, I'm not going to be able to show you or create a proper bounded context with you if you don't have a very complex problem to be solving. But I can show you how after we define which is the problem that we want to solve, well, I can show you how can we create a proper aggregate, a proper entity, and a proper value object. So I'm going to create here a bounded context about ordering. So I'll create in the core of my domain model, I'll create an order. So here I just organized the packages this way. So if you're gonna have here, in the previous domain model that I have, I create a customer package, and within that I have all of the classes about my bounded context. I'm going to create another bounded context called order, and within that I'm going to create the same package structure. So I'm going to create a package called domain.model, and on this package I'm going to be able to create what I call my order class. So I realized, well, order, probably it's an entity, so for JPA, if I want to map that with my JPA skills, if I want to model this order class into a database, maybe I can do that. Maybe I can add ID for that. And since we have a lot of time, well, not that lot of time, but I think since this is a long talk, I know that if you have some questions, maybe it get lost in time if we leave everything for to be asked in the end of the session. So if you have any important questions, I think you can interrupt me in the middle of my talk, because I think it's much easier for us to hold context of what we're discussing this way, okay? So maybe I can add an entity, and I know that some people criticize the way that I show, well, this is not how you can apply a proper domain-driven design architecture, because you're just polluting your domain model with implementation-specific details, which are the JPA annotations. But one of the tips that I want to give you, one of the alternatives that we have for, like, instead of creating our domain model, if we can create a pure POJO domain model with no annotations at all, and then we can create an anti-corruption layer in domain-driven design terminology to be applying this domain model to our database. But basically that means that we're going to replicate all of the classes and value objects and everything else in two types, in two different packages. And every time we have to change something in domain model, we have to change in the anti-corruption layer too. And to be very honest, that's the part of the system that we most often change. So I don't think it's worth to be creating two different models unless you have a very strong desire to be changing the implementation technology that you have for your object persistence, which I don't believe that will be true, because most of us will keep using JPA for the next few years. Or are we already using JPA for that? And I think it would be like a huge waste of effort for us to be creating these two layers, domain layer and adapter layer, just to not pollute our source code with our JPA annotations. Okay. So one of the tips that I like to give in this case is don't fight the framework. If the cost for you to avoid the framework in your domain model is too high, in this case I believe it is, just embrace the framework, even with all of the advantages and limitations. Just embrace the framework, because it will make your life much more easier. So order, it will have an ID. Maybe it's going to have like an order number. So I can add an integer, a number 2, an integer number. Maybe an order has some items. And if I want to create an item, maybe I have a list of that. There is no such thing here. And for now, I think that's enough. I'm going to create this class too. Order item, it needs to be serializable. And here, that's the first thing that I want to tell you. Many people implement that as an entity. I believe there's another way for us to be doing that depending on our business requirements. So what does an order item have? Maybe I have a string which represents a product. It's a very simplistic model for now. Maybe I have a big decimal, which is the amount of the product that I have. And maybe I have also a big decimal, which represents the quantity, the price that I have in my domain model. And I know many of us will just generate automatically the getters and setters for our model. And one of the greatest advice that I want to give you right now is that, is that the hardest problems that we have usually in production when we try to debug and find the cause of the problem is inconsistent states. Usually our systems keep running for a long time, and depending on the actions that we apply on our system, we can lead our system to such an inconsistent state. So we have some things that should never happen when we look at the data, especially the data that is stored in the database. We should never have this kind of information, but it is there. And assuming that nobody changed that information manually, it's very hard for us to know the source of the problem. So I would like to say that the hardest problems for us to tackle in our production code are the ones that caused by inconsistent state. Because when we're talking about code, bugs within a method because it's not processing properly or anything else, okay. But when we reach inconsistent states, it's very hard for us to try to tackle that. And one of the causes for reaching inconsistent state or reaching inconsistent state very frequently is that because we design our classes to be very mutable. So traditional way of creating our entities, our domain model entities, is to create like POJOs, and we just generate getters and setters for everything. So if I just get my IDE, which is a kind of dump code, I just expose all of the properties that I have in my class here, and then in order 2, I'm going to create the same thing. Again, I'm going to generate my getters and setters. And if you think about there's no encapsulation at all. If you think about object-oriented software, one of the greatest benefits, I think for me the greatest benefit of object orientation is the capability for you to encapsulate the data, which means your state, inside a class and create very explicit boundaries that can control the state modification inside of that. But when we allow our classes to have like multiple getters and setters, we basically were telling our source code that anybody in our system, and we're making these things public, anybody in any package can just go and modify the internal state of my domain model, and I won't even know who caused this modification. So minimizing mutability, I think it's the greatest goal of when we're trying to work with domain model. We're trying to minimize mutability. And I know that sometimes with JPA or even the other frameworks that we work for, because with Java we have the Java Bean specifications. And in many different cases, we need to provide getters and setters. I'm not sure if we have to provide setters for everything. Getters, most of the case, we need to provide because of the frameworks. But even when we do, we need to try to minimize the mutability in our source code so we can properly hold and defend the data that is inside that. So we can never have inconsistent states. So I like to advocate that all of the getters and setters that we create in our code, I don't like to generate that automatically through an IDE. I think we should be thinking very well before we expose any kind of data. So one of the things that we have to one of the ways that we have to try to minimize mutability is to not expose directly through getters and setters. And whenever we can, we should also be trying to make our classes immutable. Okay. So I'll stop here and I'll try to discuss this. How many of you are aware of the notion of entities and value objects in domain-driven design terminology? Okay, half of the people. So I'll try to explain to you what is the difference between entities and value objects in domain-driven design terminology. And when we try to create our domain model, we can identify some abstractions in our system that hold identity and some of them that doesn't hold identity. For example, if we have like, if I have to give you an example, again, every time it depends on your domain model. So if we try to oversimplify that, I'll say that if I'm going to create some notebook with which I'm going to store some context on that. If I'm going to create an address book or a contact book, I create an entity called person. This person, it might have a phone number, it might have an address, it might have a name, and everything else. So it might have a sex and everything else, and all of the attributes of this entity called contact or called person, all of the attributes can change over time, but the identity of that entity never changes. So it's always the same entity. So if I have a system, a payment system, a banking system, I have an entity for myself, I can change my sex, I can change my name, I can then change my address, I can change my date of birth, I can change my social security information, but the identity never changes. Right? So I'm always myself represented on the system. So all the properties can change over time, but I always have the same identity. In other case, there are some abstractions in our system that it doesn't matter which identity they have. For example, in the same process, if I have a contact or a person, and a person has a phone number, supposing that it's not a telephone company system. If I have a phone number, if I have phone number and my phone number for now, the number is like 111, doesn't matter for me if I change this phone number 111 to another phone number with the same digits, 111. I don't think so. So we can create two different objects with the same internal value, and I can exchange these objects within my entities, and it won't change the meaning of my software. Okay, so we have entities which are identified by identity, and we have other things called value objects which are identified only by their internal value. So phone number 111 is equal to another phone number 111. In the other hand, I can have two different entities in my system, and I can have two people in my system. One contact is called Edson Yanaga, and the other contact is called Edson Yanaga 2, but they can be different person. Okay? In fact, it happens. Yanaga is a very rare surname in Brazil. You might expect that. And Edson is not such a rare name because Pelé's name is Edson too. But if you think about that, there are 3 different Edson Yanagas in Brazil. And all of them are my relatives, you see. And one of them is my father. So you can see the confusion that might arise when we're talking about that. Okay, so you have like different people with the same internal value of name, but they all represent different identities. So basically that's the distinction between identity and a value object. Right, so for me, when I'm talking about an order, I can change all of the attributes of the order over time, but it will always be the same order. So order for me, I think it's an entity, but on the other instance, if I have a number, an order number, doesn't matter if my order number is 5 and I replace that order number 5 with another object with the same value 5. I don't think so. So order number, this one could be a value object. So I'm going to create a custom type for that because I don't want any integer to be available as an order number. Maybe for order numbers, I can have a specific requirement. Order numbers must start with 1,000. Order numbers must never start with 0. Maybe when I want to output the value of my order number, I have a very specific format. I want to output that as 3 digits dash, 3 digits dot, 3 digits or something like that. So maybe I have very specific requirements for that. And I don't want inconsistent numbers to be stored in my entity. So I need to create a custom type for that. So I'm going to create a custom type called order number. An order number, I can create a class for that. And in domain-driven design terminology, value objects should always be immutable. And I know I'm saying should is a very strong term for that. But if it's not immutable, you need to minimize mutability at all costs of your change, because again, mutability is the #1 source of problems in your internal state when you're talking about code. So one of the ways that I have to create a custom type for that, maybe I can create final because I want that to be immutable. Internally, I can store a value as an integer, but I'm not going to disclose this information to outside. I'm going to get it encapsulated here inside my order number. And if I want to create, of course, it's complaining because I need a constructor. I don't like constructors too. I don't think that we should be exposing constructors. So I want to refactor that through a factor methods. And we have some different advantages for creating factor methods instead of using constructor, for example. Factor methods can be polymorphic. You can return any subtype of order number in this auth method. You can have some custom business logic for creating your objects here too. And also, if I want to perform some optimizations, like if you've ever seen the source code of classes like Big Decimal, which is immutable in JDK, you can see that if the cost of creating an object is too high, or if I want to be able to perform object equality, Maybe I can even use the flyweight design pattern internally here when I have a factor method, and it is impossible for me to achieve that if I'm using just plain constructors. So I have many different optimizations that I can apply here. And to perform the validations and some other useful things, I added to my project the Google Guava library. And I know that when I say Guava, some people have some shivers because, oh my God, we are going to have incompatibility problems in the future because many different open source libraries that we have available have different versions of Guava. And they didn't have a nice deprecation policy in some versions of Guava. So you might have incompatible versions, and it's a very hard problem to solve. But at least on the latest version of Guava, I've read on documentation that they changed the deprecation policy. They're not going to remove like public classes or public methods anymore, which I hope will solve many of different problems. They're trying to stick to a more conservative approach for deprecation, just like the one that we had traditionally on the JDK. So to perform the validation, I would like to say that the value that you provide here can never be null. I also like to say that the value needs to be bigger than 1,000. Needs to be bigger than 0, than 1,000. Okay, show some error message too. Value must be greater than 1,000. And this kind of information I can use later, for example, to show some error message on my interface. If I wanted to have proper internationalization, I should never have like a business error message here. I should probably have just a key. So I can have value dot greater 1,000. Okay, this is the kind of string that I should be performing, because then I can get this key and then perform a lookup for internationalization purposes. That's some of the things that we can do to perform here. A proper value object must implement equals and hash code, so we're going to implement equals and hash code too. And the easiest way for us to implement the equals and hash code here, if object instance of order number, that receives the object. I can perform a cast, return as objects equals, and Java 8 brought us these nice methods. For us, object.equals, this.value, other.value. So two objects are equal if they have the same internal value, or else they return false. Also here, if I want to perform a hash, objects hash code, this.value. So this is one of the things that I can do. I think that a value object also should always implement toString. And toString for a value object, I think we should return like a string representation on its internal value. So maybe I can show integer toString value. I can perform two. Maybe my order number, I want to show that in a very nice way, internationalized way to my user. So instead, you might think, well, you could have used toString to show that, but toString, I think the main purpose of toString is to help you when you have like some debugging problems and you want to show the information that is contained in the order. So that's why usually I prefer for the value object to be just a toString. But if you want to show proper internationalized information for your user, there's a JDK interface called formatable, which fits this purpose. So if I want to show proper information, I can use the format2 method, and maybe here I'm just going to show a string, but if I wanted to show something internationalized or something like that, especially for numbers, format, I can say that's a digits, and I'm going to say value. And I could use, if you ever used string.format or formatter, with like C, printf syntax, you can use the flags, the width, and the precision here, numbers in your source code too. It's very useful. But the simplest way is to use a formatter. So I could perform a comparable too if I want to show if some order number is greater than the other. So these are some basic interfaces that we can apply in our value objects to make it more useful. So if I go back here to order, now I have an immutable thing. How can I protect my order class 2? Entities, They can't be immutable because their value changes over time, but we can try to minimize the mutability too. Okay, so if I want to protect the internal state, I don't want anybody to be just instantiating orders and just populating everything. For JPA requirements, I require a default constructor. So even though it's going to be empty, I can do that. If I want to create another constructor, I can do too. So maybe I have the requirement that my order number, I can't allow any, oops, not no. List. Okay, I'll check later. Not no, and maybe I don't want to create like no orders with null numbers, so I can protect and just create, well, all of the instances are going to be instantiated with the proper order number, and I can say that I can create a factory method, public static order of, and I can require an order number. I can say that order number is not null. I don't need to check it's greater than 1,000 or the kind of requirements because I already did that when I created my value object. I can say I can instantiate a new order. Or maybe I could even provide another constructor saying that, well, this one can be private. Private order, order number, say this dot number receives the number. Since it's already protected by my factory method, I can say that I can even return new order, and I can pass the number here. Okay, so if I need to perform any kind of validation, I can perform this kind of validation on my factory method. So I never allow an object to be instantiated in my system with an inconsistent state. And you might be thinking, well, if order, for example, is not supposed to be automated, if it's supposed to be provided by a user, the information of the order should be provided by the user, and then later I should save that. Then you can use another design pattern to be solving this problem for information that must be provided for the user. You can use, for example, a builder. Then you can allow your user to populate all of the fields of your builder, and when you invoke the build method of your builder, you can perform all the validations. So you can always create an order instance with consistent state about that. So it's all about minimizing mutability and improving the external state because we're defending ourselves from external undesired changes. So now maybe since order number is immutable, I can provide get number. I know it's not going to change. I don't want to provide set number for now. And what else? Maybe I can provide a get items, which is not a good thing for now because first, order item is mutable, and the list that I'm returning is immutable too. So I believe that we should never expose our internal collections this way. We should always provide an immutable copy so nobody can change the internal list outside the boundaries of my order class. So one of the ways for us to be achieving that, immutable list.copy of, which is another Guava class, items. And if I do that, I have a mutable list. Nobody can change the list outside this boundary. And if you see that, well, if I'm providing an immutable list, I need to provide methods to be able to change the internal state of my class. So here, get items, get number, what else? Get ID, maybe I need to expose this information to my end user interface, get ID too, and order item, I want to provide a product, amount, and a price. Product certainly wouldn't be a string, maybe a product would be a reference to my product itself, so it would be a product class. But if you're talking about domain-driven design terminology, maybe product is in a different boundary. Maybe product is in a different bounded context because we have different options for the product. Maybe product should be handled by the inventory system, the inventory module. And one of the things that we have in domain-driven design is that if we have like aggregates from other bounded contexts, we should never reference them by the class itself. We should only reference them by their ID. So if I had to have a product here, I would just reference it for product ID. And if I needed to retrieve the information, I have an order. I want to show to the end user the product name too, or the product serial number to my user interface. I would need to create a query for that. And when I would create a query, I would be creating a CQRS model for that too, which we will be creating later. okay? I won't have time to create like an inventory system with a product too. So for now, I'll just allow it to have a simple string because my external ID could be a string to an executable. Amount to, do I allow any kind of big decimal to be my amount? Do I allow negative values, zero values? How do I format them? Do I accept any kind of currency? Does my system requires me to have different currencies in my amount? So these are some of the questions that we can only answer properly if you create a custom type for amount and if you create a custom type for price too. Okay, I'll say amount, currency you should be applying for price. So this kind of thing, you should be creating a value object for that too. You should be creating a value object for amount. You should be creating a value object for price too. Because, for example, if today we don't need the currency information in our system, but later if we need the currency information for our system, we don't need to keep adding the second field in all of the classes. We just need to change the price class, add this currency information on that, and all of our system would have changed already in just one single point of change. Okay, so, but again, because we don't have enough time to be creating all of these value objects, I'll just stick with this basic stuff here. Products, amount, and price. And you can implement order item both as an entity or as a value object. One of the questions that we must have when we're talking about order item, if I have an order item in my system with a certain product, amount, and price, if I create another object with the same product, amount, and price, do they mean the same thing or are they different? I believe that for most of the systems, if I have like two different objects with the same values for order item, they represent the same thing, which means that they don't have an identity. Because if it was an entity, I would need to provide an ID, right? I would need to have an ID. But since I believe that doesn't matter if I replace one object for other object with the same value, I'm going to create these as a pure value object. And luckily, we can create this thing as embeddable, right? We don't need to provide an ID because JPA provides us for us to be storing value objects directly into my database. One of the reasons for you to be doing that is because you decided it's truly a value object and you know that you won't have many order item instances in your order. So if you're going to have like a few of them, 3, 5, 6, because one of the things that happens when you have like an embeddable class as a value object, every time you query the order, all of the order items will be fetched along the order too. And if you always want to manipulate this information whenever you query your order through JPA, then it's a good thing. But if your order has a lot of items, like if you have 100, you have 50 ones, then probably it's not something that you might want desire, then maybe you should be better server through an entity. With all of the complexities that now you need to perform there. Now they are lazy, now you need to check different things. Now, if you want to replace one, you need to delete the entity, the entity and add another one. So it's much more complicated. So if your business case is very simple and very few items, it can be embeddable. If that's big, maybe you need the burden of an entity. Okay, and here, yes. Java Money API. Even if we could have used like Java Money, the new Money API for like price. But even if we had like Money API, they have very nice things for currency conversion. They have the providers for the currency exchange and everything else. Even if we had that, I wouldn't use money as the price here. I would create a custom type, and internally, I will use money with that, okay? So because I believe that it must be a class internally, because I can say that for my system, if I create, I'll say price, and internally, I use the money API, the money class from the money API here. I could say that, well, the default currency for my system is euro, right? And then maybe I can say that for some kinds of, I don't know, some sort of currency, I have a fixed exchange rate or something like that. So this is kind of custom business logic that I provide when I have a custom type that I don't have even with the money API, right? Because it's supposed to be a generic thing. And we're trying to have some very specific things for us to protect our domain model. Okay? So we would use price, but again, I'm going to stick with plain like default types here because we don't have time to implement all of them because it consumes a bit. But all of the source code is going to be available on GitHub. I'm also writing a book about the subject, and this is the basic concept that I'm trying to explain here. And I hope that everything will be better explained in a book. Organize it. Here, because I want to show these things on interface, maybe I need to provide the getters. And I'm safe for now because both string and big decimal, they are immutable. But I can also check, well, I don't want to create any kind of order item. I can't allow null values. Also, I can't allow any kind of amount. I can't allow any kind of price. So for JPA, because of JPA, I need to provide a default constructor. But if I want proper immutability, maybe the best way for me to achieve that is to always create consistent objects. So I want to create a constructor with all the fields, and I want to refactor that with a factor method. And here I can check everything. I'm just going to check not null for product. I'm going to check not null for amount. I'm going to check not null for price. And all of these constraints that I'm creating here, I'll be able to use on my JSF interface later too. So here, I just create an ordered item, get here back to order. How do I store a list of value objects if they're all embeddable? So maybe if it was an entity, I would have to map that as a one-to-many. But if I want to map that as a value object, I can use the annotation for element collection. Element collection. Now JPA automatically treats that as objects. Every time you change the list, for example, if you add an item or remove an item, JPA, well, at least on Hibernate, I believe it's going to delete all the items and insert them over all again. So just like I said, it's only practical if you have very few items in your model. If you have too much, maybe you need to think if that's a value object or if that's should be modeled as an entity for performance reasons. But for very simple use cases, I like to show that as an element collection because not many people are aware that you can do that in your domain model. Okay, so we have order items. Order item is immutable because I never allow an order item to be changed. After I created one, I expose it through getters. To be a proper thing, I should be implementing equals and hash code 2. Hash code 2. I'll just leave it without a nice implementation for now because we won't be requiring. But toString also, what is the here? It represents a value object, but it's a composable value object. Maybe for me, for debugging purposes, it's very important for me to know the internal state of the object because I won't be exposing outside. It's just for me as a developer. I know. Or at least I suppose I know what I'm doing. So one of the nice classes, this one needs to be from Java. I can create a toString helper, which is deprecated, by the way. And I didn't realize that. More objects, perfect. Products. Products, so thank you. It can be amount, it can be price, toString. So this is a nice way for you to create your toString when you need debugging information. And we should be providing the same thing here, for example, for order. So if I have here my factor method, maybe I should provide toString. And again, as an entity, I should be providing a proper equals on the hash code for that. I won't be doing here because of the time. Here I can use more objects. toString helper. And I can add, maybe I can add the ID. I can add the number. toString. I don't think if you have a huge list, I don't think it's desirable for you to know to print all the lists because the debug information will be like huge. But maybe if you want to know that the item size, for example, you could add this kind of information if that's important for you to debug if everything is working properly in your system. You can be assured that items will never be null, so you won't have a null pointer exception when you're trying to do that, okay? But one of the questions that arises is that, well, we're trying to create proper value objects, proper entities, and everything else. How do I map these things to my database? Because JPA knows how to store a long, knows how to store a string, but it doesn't know how to store an order number, for example. And to answer that, here in my domain model, I'll have to create infrastructure. Okay, I have to move here. Order. Inside infrastructure, maybe I can create another package here too. Persistence, I'm going to say specific to JPA, and I can create something that since JPA 2.0 we can provide, which is an order number attribute converter. So if I will provide this class, I just say implements attribute converter from order number. And I want to store the number in my database as an integer. So, and I want this to be auto-applied. Converter, auto-apply, true. So every time JPA found an order number in any of my classes, it's going to apply this attribute converter to be right into the database and to be creating my instance from the database too. So the two methods that are important for me to implement are convert to database. So basically, if I have an attribute, I just say attribute dot, and now I say value, but value is encapsulated. I know it's an integer, but it's not exposed. So how do I solve this problem? I need the internal value of my order number, but I don't want to expose that. If I just create a get value getter, I think it exposes too much information because it's just, when you read like get value, you're just assuming that you have an internal property called value too. That's why I like to say that instead of get value, I like just to rename the methods to value because I'm converting my order number representation to an integer representation. So later, maybe I could provide a too long or too big decimal or to something implementation. So I'm going to create a two integer, and then I'm expose the internal value. If I get here to integer, and if I want to do the opposite, return order number dot off, and I can get the DB data. So that's the simplest possible way. And I believe that until JPA 2.1, this kind of attribute converter, it wasn't called for new values, but now for JPA 2.1 and on, it's called for new values too. So if you don't want to handle nulls in your entities, you can provide like very nice null objects in your system by applying the null object pattern directly here in the attribute converter. So if you want to check, well, maybe from the database, I'm retrieving like a null value, but I don't want to expose null to my application. Maybe you can return order number dot off, and we had a requirement must be bigger than 1,000. So maybe you could say the default value for that. Or you can create a specific null object for you, which will create a behavior, and you will never have a null pointer exception when you're trying to show something in your system. So it's up to you. Here in the attribute converter, you can use null objects, or you can use some other strategy. Or if it's okay for you to be using null, I usually don't recommend that. It's okay for you to be doing that too, okay? But I think it's only after JPA 2.1 that is properly calling converters for null values too. If I have this kind of information, it's going to be properly persisted on my database. And on the other side, if I want to have this kind of information, to be shown on my interface, JSF doesn't know how to show this information for my user. I need other kind of converter too. Luckily for us, for JSF, we have like just to have an attribute converter, we have a faces converter for that too. So if I create here, the package, view, package, no, create package. And if I want to create here a Java class, I can say order number, faces converter, or it could be just a converter. Implements converter. I can implement the classes. Oops. Let's converter. I can implement the methods, and I can use an annotation, faces converter. For class, it's order number dot class, so it will pick it automatically. By my JSF implementation. And what do I need to do here? Here I need to check if it's null, value return null, object order number of, and I'm receiving information as a string, and I need an integer value to be put in that, so I'll need to convert that in some sort of way. So integer.parse int value, and you know that this method can throw an exception if you don't have like a proper thing. So the proper way for you to capture this kind of information, you can encapsulate that with a try catch, number format exception, yes, format exception X, and here you new faces exception, new faces message, just throw a message here, invalid order number. Okay, for now, and get as a string, I can just if value equals null because it can return null. Else I can just cast it order number. Order number receives the value. Order number to string. If that's the way that I want to show the information to the user, if I want to form that in a different way, maybe I can use string.format. I can say that I want to format that as a string, and I want to pass the order number object for that, because whenever I use format, it's going to use a formatter. And if I'm using a formatter, the method that is going to get called is this one, format2, where I can apply all the internationalization and other custom formatting logic that I want. Okay? So I will want to issue some flags. I want to represent that in a formatted way, or I want just the numbers. You can use the formatter interface flags to signalize that for methods. You can say which is the width and the precision, which definitely you should be implementing, but I won't be doing for now. Again, because it really depends on the business logic, and it takes some time to be doing that properly. Okay? If you just did that, then maybe you have a proper faces converter. It's going to be okay for me to be creating this here in my interface. Okay. So I have order, lost here, order. I know how to store order, I know how to store order item and everything else. Next question is, well, if my items are immutable, how do I add some information here into my, my list of items? So maybe you need to add a method called an adder, order add item. That's one of the ways that you can add that. You can always return these just create a Fluent API, and then you can compose your method invocations. You can check here. No items, so you can never receive a null item. If anybody tries to add a null value here, you're going to have an exception raised just when you try. That's one of the ways that you can protect your code, because it's much easier for you to spot an error when you try to modify the value rather than when you try to consume that. You can always check not null here. And maybe you can use items.add item. You could always check here, well, I don't want to allow repeated items to be added to my list. So if I detect that the same product is going to be added on my list again, I want to block that. I want this operation to do nothing. So maybe I could say that if items.contain item, or if not items.contain item, I can do that. But for me, for this thing to properly work, I need to implement properly the equals and hash code here, because they're just comparing like object equality. Identity equality in the Java sense, so it's not very useful for now. But if I wanted to do something different, if I don't want to read repeated items, I would add this kind of check here in my source code. And if I wanted to do even something different, maybe if I detect that two items, if they have the same product, then I consider it to be equal. And what do I want to do is that if they have the same price, I just want to add both of the amounts and create a new item replacing the other one. So if this contains, then maybe I can create, items contain item, I can remove, I could remove the previous one and add, sorry, I'm having a hard time breathing. I'm just recovering from a cold. And I could remove the previous item, then I could add the two amounts, create another object, and back that list. All of this, they can be added here if I have an add item. And this kind of information will not be scattered around my source code base, because the traditional way of trying to add this kind of business logic is that you're going to create a service, and every time you try to add an item, you're going to get the list, remove the item, add it back, and everything else. So maybe if you want this kind of logic to be implemented in another place in your system, you're going to copy paste your source code in the other spot too. You don't want to do that. So here you were just centralizing where you can change the state of your order. So everything will be done here in the order item element. Okay. So these are some of the things that we can do. Other things that I want to show you right now is that for some things we can apply the state pattern inside our entities too. And for me, one of my favorite features of the language is the enum. So I want to create a key. I want to create here an order status, and this status I want to create that, or maybe order status or order type, because I want different order types to be processed. Maybe the user is paying a premium and he wants to be delivered faster, he wants to be processed faster. I can do that too, but I just want to show that I can, the same logic that I created for a custom type, I can use for enum too. Enums are serializable by default. I can say that I might have a premium, and I can have like a default one. And some people don't realize that enums are full-featured classes, so I can implement any kind of things inside enum. I can implement an interface. For example, I can implement a function that processes some order items to order item. I can do that too. I could be providing like some sort of discount. So there are many different things that I could be doing with enum, but for now I'm just going to say that until JPA2, particularly in Hibernate, we have this problem. I didn't check other providers like Eclipse Link or Toplink. We had a problem trying to persist enums with custom types. So the traditional way of you to be doing that would be using enumerated, and if you're using enumerated, it needs to be enum type ordinal, which is position based, or you could do that as a string, which is going to store everything like premium or default in your database. But maybe you don't want to store that just as a premium or default. You want to store that just as a single character in your database. So maybe you can add some fields to your enum, like private final string value, and you can add a constructor to your enum, and you can say that here premium is with a P and default is with a D. Okay, And you can say, well, to string, maybe here it's questionable if I want to provide that to database representation. Okay, and I want that to return a public string return value. Okay, that's one of the things I can do. And if you have an order type, when you create an order type attribute converter from order type, and you can store that as string or as a SHA-2, it would work. You just need to be sure converter auto apply true. Now it works on JPA 2.1. I don't know if it was a bug in Hibernate, but it's working properly here in the latest version of Hibernate 2. And you can say that attribute to database representation. And now we need another method, because if I want that to work, order type of, and I need to create a method, maybe dbData. How do I implement that properly with enum? I need to create a map, which is an internal right stack final map, saying that I have, if I get a P, it has a string, I want an order type map. I can use a value map, and before that I use, before having like Java 8, I needed a static initializer just for me to populate this value map. But if I have Java 8, I could just say that I want to create new order type string of values dot I don't want to map collectors to map. Here I have the type t.value, t, I have t. Okay, so if I want to create, now I have a map which maps the internal representation to my proper order type, which is kind of a neat feature. The problem is that this map is not immutable, but since it's private, nobody's using from outside, I can guarantee that nobody will be changing that. And I can create just a factory method here, which can be public order type of string value, or maybe since I know it's going to be dbData, return value map.get dbData. And if you, for any instance, you just pass like a C value for my order type, it's going to return a null. Maybe if it's going to return a null, you could return a default value, get, or default. Maybe you can say, well, the default value order type dot default. That's another way for you to provide a default value, so you can never have a null value in your class. So if I get back here to my attribute converter, order type of string. What's the issue? Static. It needs to be a factory method, okay? Now it's working properly, and I think that's a proper way for you to be handling enums. But after realize, what can we else do with enums? They are polymorphic, so we can apply different operations for here. I could say that, well, if I check here that the total price, if I want to add a method in my system that just calculates here, well, I want to know how much, which is the total price of my order. Maybe the best place for me to calculate that is inside the order class, because it already contains all the data, instead of creating a service method which will calculate outside of my data. So if I want to create here public get total price, if I want to be doing that, I already have access to the items, and since I also have like my order type here, I know that if it's a premium thing, I have to remove. I know that if it's a premium thing, I can apply a discount, for example, 10% discount. It's another way for me to be calculating that. So what can I do with total price? I could get my items. I could create a stream. I could say that I want to map all of the items that I have. And I want to say that if I have an item, I want to get the price. And I want to reduce. And if I want to reduce, I want big decimal. And I want to start with a big decimal dot 0. Oops, big decimal. Oh, where's the bug? Sorry? First, oh yeah. Okay. It's very hard to do these things like live coding in front like lots of people. And then maybe you can return these kind of things because by default it's just summing the amount. Maybe I should be multiplying by the price with the amount too. But if I want to apply a discount for this total price, maybe I could apply a function for this. So instead of just putting a map here, I could add another map, and I could say that I want to get my type, and I want to use like a get discount function. And if I want to add this to my type, which is not a valid order type. If I want get discount function, I'll get here first order type. Oh, sorry, order type. So now I want to implement a function which returns for me a big decimal. I could be implementing directly. I could have a map if I want to have the different functions, not only for discount if I want another one, but if I want to implement a function here, I would say that apply. Here I'm going to apply return the own big decimal. Here I can just return big decimal, multiply, new big decimal 0.9. Okay, I'm going to give like a 10% discount on my orders. So I get back here to my order. I can just go order. I want to map because I need a function. And it's going to be applied on big decimals. I can just say here, order type. Because already a function, and it should be working properly too. Okay? And if I wanted to apply different types of function, then it's not, if I want to have like a polymorphic behavior, order. Inside here, maybe it's not a good idea for my order type to be implementing directly the function. Maybe I could just create another map with another set of functions. Then I can have like, I could create a public function. Big decimal, get discount function. Then I think it's a nicer way for you to be implementing this kind of polymorphic behavior if you have more than one function to be applied on the same type. Okay. So these are some of the alternatives that you can apply if you're using another. As I said, enums are full-featured classes. And what can you do? Enough for now. We're just creating the value objects. That's most of the tips that I wanted to show. I have others, but I don't want to spend more time on that. Now I'm going to talk about my other domain model, because I have another one which are called customer, and on this one I had the time to create all of the value objects for everything, and I have a proper interface working here, and I want to initiate a discussion about CQRS. Okay? The traditional way for you to be creating this kind of interface is that you create an entity, you store that on the database, and if you want to retrieve the information to be shown to the user, maybe the query that you're creating here in your interface is something like this. So let's create a customer repository. And if you want, so here I'm using a tool called Query.sl that allows me to generate this fluent fluent DSL for me to create my queries. But what I'm doing here, I'm just creating like from JPA, I'm just creating a query like from customer and retrieving everything and applying a where predicate to my entity. So basically I'm retrieving from all of the customer objects that I have stored, I'm applying a filter with a where clause, and I'm returning and asking JPA to just populate the customer instance with all of the fields that he has, and maybe the customer has an address list, maybe a customer has a phone number list, maybe the customer has a credit history list, maybe the customer has a lot of different dependencies, and just for me to be able to show this information on screen, and I'm just showing name and surname, I'm going to populate my entities in memory with all of this information from the database. It doesn't seem to be a very nice approach for me to retrieve information from the database. And if you've seen, there's a talk on YouTube from Greg Young, which is the person that first referenced the term CQRS, Command Query Responsibility Segregation. And basically, when we're discussing domain-driven design and CQRS, means that with CQRS, you can have, or you have, different models for reading and writing your information. Basically, if you're performing writing operations to your domain model, you are going to use your customer class, your customer aggregates, and your customer's entities and value objects inside of that for everything. But if you want to query the information, and maybe you want to show the customer information querying from different tables, different aggregates, different entities from your database, you won't be just populating your aggregates in memory and picking through getter the information that you want. Maybe you want to create a CQRS representation, and that's what I'm going to show you today. Now, I'm pretty sure that most of you did this in the past. So if I have a customer here, this thing that I want to show here just show me the name and the surname, and if I have the representation, I don't want to expose all of the customer information. I'm going to create a DTO. So for a DTO, a customer DTO, which is serializable too. And here I'm going to say that it has an ID, which can be final. It's going to have a final name. It's going to have a final surname. It's going to have a constructor. And just because it's JSF and I need the getters, I'm going to generate the getters. But it's immutable, so it should be safe for me to be creating. And if I go get here to my customer repository, I'm going to say that when I query that information from the database, I'm not returning the customer by itself because it might have a lot of information that I don't need for now. I'm just going to create a customer DTO and select. And instead of returning the customer by itself, I'm going to build selection, projections, constructor. I want to create a customer DTO dot class, and the information that I want to query, ID, name, surname. Okay, as I said, all of the source code is going to be available for you to check later. But I think that Query.sl is a very nice way for you to be querying your entities. We're using a fluent language. It uses a Maven plugin. I believe it has a Gradle plugin too to be generating your Q classes, just like you would be using like the criteria from JPA, but this is much nicer. I think this is the way that should be provided. If you want to create JPA queries, so if you want to use a rich domain model, you want to keep using like your name value objects, your surname value objects, or your order number value objects, then it's nice to be using Cured SL. But if you have like very strict performance requirements, if you want like low-level control of your SQL statement, if you want a richer access to your SQL database, then maybe you should be using either native SQL, or you can use a tool like Joke, which was created by Lucas Eder. I don't know if he's going to be available at Devoxx this year. But it's a very nice tool that just introspects your database and generates like a DSL for you to be creating your SQL queries, just like I'm creating a JPA query here. Then you have like the full power of your database in your hands. It really depends if you're very performance oriented, you have very hard queries, you want to create your CQRS read models with that, or if you want to stick to JPA, you can just keep doing that. Okay, so when people talk, what is a CQRS architecture? Just remember, we've been doing this for lots of different years, many years. We just didn't know that it had this name. So CQRS stands for we have a model, and this model for now means that we have different sets of classes for reading and writing operations. Writing operations are performed directly by the domain model. You modify the customer class, and you ask your repository to persist or to merge through the entity manager your customer entity to your database. But if you want to query this information from the database, you're going to create a custom query. You're not going to retrieve all the information from the customer, and you're going to show this custom customer DDO. Maybe you wanted to join the customer information with other data source and show here too. You're going to create a custom DTO specifically for this query. You're going to retrieve that, and you want to run. So without changing anything, I can show you the same interface because by coincidence, oops. Okay, controller. A customer controller. If I have here, since by coincidence, I just I think it's right. I have both DTOs. Oh, yes. Oh, sorry, I already had a customer DTO. I'm creating another one. Name, surname, which happens to have this almost the same values. I'm just going to delete one. Come on. Here. Okay, now it's working properly. And the customer DTO, now I can run it. And since they happen to have the same like values, name and surname, my interface is going to keep working at the same without any further changes. Just want to run to make sure it's working. It always takes longer when you're showing something on screen. So here, yes, it's still working. I can filter that. If I have time, I'll show you like a nice way to be creating the spheres. Spheres I want here. Okay, this is working properly. And this is the very first step for me to be able to be creating my CQRS architectures with event sourcing and domain-driven design. So just have in mind, for us, for now, CQRS architecture means I have different classes, different models for reading and writing information. The next architecture that we're going to create is that we can have like CQRS architectures with separate data stores, because you don't need to read and write your information from the same sets of tables from the same database. You can read from different sets of tables from your same database. You can read from different sets of tables from the other database, and they can be synchronized through different ways. And after you create your CQRS data store, your CQRS architecture with separate data stores, then event sourcing can become a reality, because after you have a distributed CQRS data store, then it's up to you to decide if you want to store your change events in an event store, or if you want to keep using your same old legacy representation that you have. But I want to show you that after a quick break, because we've been talking a lot already, and I think we all need some rest. So see you back in 20 minutes, okay? And we're back. One of the good discussions that I had here in the break, some people were saying that somebody asked, if you're not supposed to get a service and get all of the business logic inside the service, if I'm trying to push some part of the business logic inside of the entities and aggregates and value objects and anything else, how do I decide in which objects do I put the business logic? And one of the good things, one of the good questions that I always like to ask the teams is that who owns the information in which you want to manipulate it? So basically, if you have a service, you just queuing objects, and then you just start to get this object dot get this information, get this information, get this information, like process it, and then set this information somewhere else. Maybe you're performing this kind of logic in the wrong place. So I think it's much easier for you to perform the logic, the business logic that you need to perform inside the object that contains the information. So that's one of the reasons, okay, that's a very simple model, why the total price was here instead of being a service and calculating that outside, because the order is the one that know the items. I'm not supposed to be queuing the items directly because it would like leak the information from inside the order. Maybe I don't want to expose the internal representation. Maybe, in fact, when I insulate my code from this external exposure, maybe it can be that even the order item class that I'm exposing here in the getter is a different class than the one that I use internally to represent that. I don't even need to store that as a list. I could be storing the things as a map, or I could the opposite one. I could be storing my items as a list internally in JPA just because it performs better. But I could just be returning the items as a map, like mapped by something like for the ID, for example, or any other for the product or something like that. So it's very important for us to separate this internal representation from the external representation. Sorry. So you should always be performing these kind of things in the object that contains the information. And in this case, order contains information. Another question was that, well, maybe if I wanted to perform some very complex calculations and I need to create a DTO, I needed to create a CQRS model, which was joining information from the customer, from the order, from the items, or maybe something else from the product, because this particular customer, depending on the kind of coupons that he has on his accounts, he might be eligible for different kinds of discounts on different kinds of products. And this kind of information clearly is not contained is only inside of order, nor in customer, nor in product. So maybe one of the approaches that could be done in this situation is that you create a CQRS model. You create like a discount DTO, discount query DTO, something like that. You query all of this information from your database, which is scattered through different entities and different aggregates. You just get this information, and inside a method inside your CQRS model, you just perform all of this. So this is one of the things that we can be coding when we create CQRS models. Okay, I had, and I'm sorry if I'm speaking too fast. I just have like many different ideas and concepts that I would like to explain, but it's always a challenge to do that while coding and talking to you. So, because it's very important for us to focus on the distribution part, and now I want to exchange a bit instead of just coding the things. I want to show you how can we use this knowledge. Sorry. How can we use this architecture and code that we created right now for distribution? And I want to emphasize one more time. Traditionally, CQRS models, CQRS architectures have been used in the Java world for performance reasons. So whenever we needed to perform a query that aggregated from multiple different places, and we want to perform a computation or show that to the user, we created these DTOs, which is our CQRS models, to have a better performance. But when Greg Young created the term CQRS architecture, initially it was intended to be used as a step towards an event sourcing architecture. But since when we created this term like 10 years ago, it was very hard for people to grasp the concept of, well, now the state of my data is not anymore a row with some columns in my database. Now the state of my data is a stream of things that are happening, which we call events. So we have a lot of different events working and being applying all the data, and I don't have anything else anywhere else to query my information. It was very hard to grasp 10 years ago. I think it's still hard to grasp. That's why he created the term CQRS. So CQRS, we were able to apply successfully CQRS models for performance reasons. Now we're going to apply CQRS models for distribution purposes. Because if you're talking about distributed systems such as microservice architectures, it's important for us because we need the data that now it's supposed to be splitted in different endpoints. We need these different pieces of data to establish some correlation to perform some business logic. But if it's distributed again, usually it's not feasible for us to, well, just create a REST endpoint whenever we need the customer information or the order information or the product information. We're going to execute like an HTTP query and query information from the remote endpoint and perform our calculations. I know, and I think that most of you realize, that if you deploy this kind of architecture into production, usually it doesn't perform well. Usually it means downtime because you have some very serious scalability issues. That's why the traditional step from most of the companies that I visited and working when trying to distribute systems is that, well, we created a proper, at least we found that we created a proper bounded context. We created a microservice. Now we need to integrate the data to perform something. Let's create a REST endpoint here, and we have a REST client. Just queuing information, perform the computation that we need, and keep going. You deploy this thing, it's very low, it's low, it doesn't scale. Then you realize that, well, if it's a performance problem, we need cache. Then you have more problems. Then you realize that, well, an internal cache, usually you create a map, for example, to be caching, or a weak cache map or something like that. Then you realize that your map's not big enough. You create a cache service. Usually you deploy something like Redis or a memcache just to store your objects in a key value store. Then now maybe my cache is big enough. Then I have other kinds of problems because in my old legacy monolithic enterprise information system, I need SQL because I'm performing like very complex queries. I have like different CQRS models that I need that I created in the past for performance reasons, and now for some strange reason they don't work that well anymore because I have to join the information that is on the database with the information that is in a key value store. Isn't there a better alternative to be creating this? And I would say that maybe for some systems, storing this kind of cache information from a microservice as in a serialized object is an appropriate solution. But I still believe that for many enterprise systems, or for most enterprise systems, and I'd like to remember all of us that like 90% of the developers in the world, they're still developing enterprise information systems. We still need the capabilities of the SQL database. And how do we solve this problem? So what I want to show here is that just as I created this customer DTO representation here in my read model, I can use this information to be creating and extracting another kind of model in a separate data store. So, sorry. If I have here a customer class and I decided that the customer bounded context is simple enough, and you might guess, well, in the business real world, my domain models are never that simple, but I just want you to have a notion of what can be done here. And if I decided I want to, the customer bounded context is an ideal candidate to be moved to a microservice. So we're going to expose that. And the customer microservice, of course, is going to retain the customer information. All of this information is going to be stored that. And I have to remove the customer information from my monolith, which in this case will only have the order bounded context, but it could have the product bounded context too, because in the monolith, everything is scattered around my code base. If I want to execute that, then I move it there. I need information here. So we are going to create two different models, the canonical model, and for me the canonical model is the canonical source of information, meaning that the true source of information is going to be stored in the microservice, the customer microservice. So if I want to know which is the value that customer has in this exact moment, is the customer, but since I need information to be performing some queries inside my enterprise system in my monolith, I need the CQRS read data store in my old monolith. And how do I create that? So, and at least I hope that it will become very clear why it is an appropriate architecture for you to be creating your event sourcing architecture later. So if I have customer, I'll just exit the presentation mode for now. I just created another project here, which is a microservice one, which is empty for now. The only thing that I've added for now is some dependencies that are going to be used in common. And I chose to, on purpose, to be again a wildfly swarm project because my monolith is using Java EE, and I want to use the exact same code and maybe reuse the code that I had in my monolith. And if I created the bounded context properly, if I properly packaged all the classes, and if I created the proper CQRS read models so that the business logic from the customer bounded context is not scattered in other classes too, I should be able to just like copy and paste all of the customer information, and the rest of my system should still keep working. So what I'm going to do is that I'm going to copy the classes from my monolith here, from the customer bounded context. I'm just typing Control C. If I go here to my microservice and type Control, I want to copy the files. And I just copied everything. Since they're in different folder, I can copy the customer HTML file, the JSF files. I put here the customer. And maybe that should be enough for me to have like something working in my microservice from the code point of view. And I need to copy the data too. So what I'm going to do here, I have a script ready to go. I'm going to basically want to show, I'm here to, basically I'm going to perform a migration. I'm going to dump all of my customer information into a SQL script from my monolith. So if I open here, I'm going to dump that into a SQL statement. Okay, it's unsafe because you all know my password. And I can import that into my microservice database. I'm just going to get the information and pipe that to my MySQL client, importing that into my microservice database, which is another instance of a MySQL database running. Supposedly it should be another host, but I have two different MySQL servers running inside two different Docker containers. So now it's populated, and if I want to check the information, here if I check my microservice database, I have this information here from customer, and if I open here my MySQL console showing my monolith. My monolith has the schema version table too, which was created by Flyway because I populated the database with a migration. If I check here, for now, they have the exactly same information, right? So I'm trying to create two separate CQRS data stores. And since I'm deploying a new microservice, I needed to perform this migration. It could have taken some time, but since my data is very small, it was took less than a second. So for now, I have two separate data stores which have the exactly same information. But I want my microservice to be the canonical source of information, so I don't want my monolith to perform any kind of operation anymore on the customer table, because it's not the canonical source of information. And if I could get here the monolith, I could just delete the JSF things, I could delete the services, the business logic, and everything else. But since the microservice, and I want to check if the microservice is going to work. So I have here my microservice. I want to run it and check if it's going to perform the operations. And since my bounded context, you can see it didn't have any other dependencies on other classes, which because it's a clean model. But in traditional enterprise system, it would be very typical in a bounded context for you to be referencing the entities from other bounded contexts. And for you to be able to perform this migration, the easy answer is that for any kind of reference that you might hold for entities in different bounded contexts, and technically you should only be referencing aggregates, the root aggregates from other bounded contexts, but I know that in legacy systems not the way it works. You should be performing something like this. If I get into the monolith, and one of the things that should be important for us to note, an order probably would have a customer. So if I have here a customer, and I need to import from another bounded context, traditionally people would use a many-to-one, which is not a nice thing too, because when you put a many-to-one here, it's going to be fetched like eagerly from the database, so it's going to join from the customer information. If the customer has a lot of fields, you're going to have even bigger performance problems. So usually it's not a good idea for you to be creating this many-to-one relationship if you need information from different bounded contexts, right? You can use many-to-one relationships if you have only one aggregate and you're just performing data manipulation inside your aggregate and the internal entities. It's okay for you to be doing that. For things outside your bounded context, not that good. So instead of just creating a relationship, what would you do? The ideal way would be to create another value object, which is a customer ID, and to go to customer and change that to customer ID too, right? But for this particular example, JPA still doesn't allow me to use attribute converters in the primary key, so I would have to dig into JPA to the JPA provider in specific implementations. I will have to go dig into the Hibernate user types just for me to be able to use this customer for the example. And I didn't want to add this kind of complexity now. I just want to let you know that it's possible. But then you have to go, if you're using Eclipse Link, you have to do the Eclipse Link way. If you're using Hibernate, you have to use the Hibernate way using user types. So, because I want to keep it simpler, I'm going to say that the ideal way would be using customer ID here too and customer ID there. For you to be later, when you create a query on your CQRS model, you'll be able to join that properly. But since Since it's going to take a lot of work for now, we're going to leave that with a long value and say that it's not a customer, it's a customer ID. So basically we're referencing that. Since customer is from a different bounded context, I'm not creating a many-to-one relationship. Every time you create a many-to-one relationship, you should be thinking, is that at same aggregates? Is that the same bounded context? If the answer is no, then maybe you shouldn't be using a many-to-one. You should be using just a plain type. And again, if you want to dig more, you could be creating a customer ID type with a hibernate user type. That's the ideal point of view, but we're not doing that today. So if you want to reference, I would just create a customer ID. Then I would be able to move the whole customer information from here to the other microservice because I wouldn't need the customer class in my order code anymore. Okay, that's one way of thinking. Right? So my microservice has started. So if I access here my endpoint, I know it's very small. If you access my monolith was in 8080. If I want to access my microservice, it's going to be running 8081. I have the exact same information. Now it's performing. If I want to update my name here, it's Edson1. It didn't work. Customer controller. The package is wrong. Customer controller. Well, it compiles, which means nothing, of course. It worked before I started this presentation, if you want to trust me. Method not found. Controller. Oh, I'm passing a DTO. Yeah. So here, I just changed it before. I want to change it back. Customer. So here, I'm going to change to customer DDO. Select from here, customer. Okay, customer repository and customer controller. Okay, in my microservice, because here I'm not going to need my CQRS representation, at least for now. And even if I wanted to work in my CQRS representation, it would be a quick fix. I just want to do it now while I'm coding. So I want here, it's not Edson1, it's just Yanaga. Now my names are correct. If I go back here to my database, my name doesn't have the 1, but in my old system, my monolith still has the 1 information. So once I just split the database and I copy the information from one to the other, the canonical source information is now is my microservice, but I need the custom information from my monolith, preferably inside my database because I want to perform complex joins to create my CQRS models. And in fact, that's the approach that I recommend for most people, but you must have a way to synchronize the information from your canonical source, which now is distributed, into your monolith. And the best way, again, for enterprise systems is to create a CQRS data store. Some people call that a cached copy, a copy table inside my monolith. You can call that the way that you want. I'm even keeping the same table name here, customer, because I don't want to change anything else inside my monolith. I want to have the same queries, the same DTOs and everything else. So what do? I need some way to synchronize these kind of things. The best way for me to achieve that, well, in fact, I said best way. I think how do I put that? I think the way that we want to perform this kind of integration is through messaging, because maybe somebody might be thinking about event sourcing later. But in my book, I describe many other integration techniques. You could be using a view, you could be using a materialized view, you could be using a CDC, you can use a tool like Devoxx to just broadcast the transaction log from your database into your remote read data store. So that are some alternatives. But since we're in this domain-driven design demo, we want to go to the path of event sourcing. We are going to generate change messages from our application, from our microservice, and we want that to be propagated to my remote monolith. So what do I have here? I'm going to create a new service. And sorry, I won't type all of that here because usually when I type that, I make mistakes. Customer, so okay, customer infrastructure. Let's create another package. GMS, and I'm going to create a customer notification service. And if everything went well, I'm just copy and pasting the codes. I'm just creating here. I need a JMS broker. I created a topic. And for every time that I change my information inside my system, I'm going to broadcast a message on a topic saying, well, now I have I have a notification from anybody interested in customer events, customer change events, because now I have in my system a customer that is new or has been updated, and I'm going to broadcast this information as a JSON payload. Because couldn't you be just broadcasting the customer class? I could, but then I would be tired. All of the endpoints in my system would have to be Java applications. All of the endpoints in my systems will need a shared library containing the customer class. I don't think it's a nice approach if you want to insulate changes from one endpoint to the other. So that's why we're using a text payload. Could be XML, could be something else. We chose JSON for this example. So we're using JSON-P from Java E to Java E7 to be creating this information. So I'm just broadcasting the ID, the name, and the surname of the customer that I created, but I'm not broadcasting just a class that allows me to send this notification. And here, sorry, in the customer repository, which is a central point of change in my system for customer-related information, I'm just going to say that whenever I save any customer, here I want to send a message. So I'm going to create customer. I want to inject this kind of information. And here, whenever somebody tries to save it, I merge this information and I ask customer notification service. Sorry. And I want to send this information. But for that, I need a JMS broker. And to be very honest, I spent nice hours trying to find the easiest way for me to configure and deploy a JMS broker in my machine for performing a demo. And I was very surprised because after trying many different Docker containers, installing and configuring by hand, everything, I just found that Wildfly Swarm was the easiest way for me to deploy an active MEQ broker inside anywhere. Because all I had to do, I just went here to the Wildfly Swarm website, generator, I just asked it for messaging with ActiveMQ. Is it selected? Messaging. Why is that? I'm not seeing. But just, here, messaging. Just generate the project. It's going to download a self-contained FatJar application, and I just need to configure the name of the queues that I wanted. So here, I have my Maven project as a broker. You can see It's a wildfly swarm application. I just called it JMS broker. It just has the JMS, the messaging fraction here. So that's everything that I need to have a full-featured active MQ broker. And I just needed to configure the YAML file for wildfly swarm, which in this case is this one. Once I configure that, I just said that I want to listen on this port. I want to create this topic, customer topic, and everything else you just get from the documentation, just copy pasted the information. And once I did that, I executed a clean package, and if I did that correctly, I just have to run this fat jar, and it's going to have like an ActiveMQ broker running inside my machine, which will be used by both my monolith and my microservice. It's up already. Since it only has the JMS dependency, it's very fast. So now JMS is running. I'm going to stop my microservice here because now it's able to send notifications. And I'm going to run again. And once it gets up, my microservice, anytime I save any kind of customer information, is going to broadcast that information as a JSON payload on my JMS topic. Now everything I need to do is to consume this kind of information in my monolith, so it will be able to update to update my CQRS read data store, which is stored in my monolith, and everything can keep working the way it was before. So now it's okay. If I go to my interface here, my microservice, you can see that the information is here. If I still go to my monolith, it's not running. And now I go back to my monolith source code. Monolith, okay. And I have to be very honest with you, I cheated on this because I didn't want to type all of these annotations again. So I have it ready. But basically that's just standard Java E 7 annotations for a JMS topic. I just wanted to say that I'm creating a message-driven EJB, a message-driven bean, which will have a message listening implementation. Whenever I receive a message, I want to get this JSON payload, convert that to some kind of information that I can store as a customer, and then save this customer. So it's just configuration. Here I have the customer repository, which is still a copy of the one, well, now it's not exact copy anymore because the other one is sending notifications. Since it's JSON, it's a text message. I'm just seeing message received. I create a JSON reader. Then from the reader, I create a JSON object, reading by that. And what do? I'm not dealing with the case that I'm deleting a customer. I just ask the customer repository to find the ID, because the ID I get from the payload. I set the name, I set the surname, and I save it. You can see that it won't work if it's a new customer, but I just want to show that I can integrate some data. So this kind of information is saving here. So let's put it to work. Running my monolith. Okay, it still has Edson 1, Yanaga. Let's try to change that again. If I put here, Edson, Devoxx. If I hit save, if I go here for the log, the broker, something is happening. I'm receiving a lot of messages, which was not supposed to happen, but well, it changed, okay? Okay. I should have hidden the console. But, well, apparently it entered into a loop, which was not happening before, I guarantee to you. But now it has just updated the message. And, you know, it's a very simple demo, oversimplistic demo, I agree. But I just want to show that we just created a CQRS architecture from a very simple model. And JMS is one of the possible approaches that you can have to try to update your read data model from your monolith from your microservice. This is one of the simplest things, the one that I could show you using plain Java E. Many people will use Kafka for that. Some people, as I said before, you can use a view, materialized view, you can use an ETL tools, you can use CDC, you can use a message broker, broadcasting this very stupid message that I created with a JSON payload, just saying, well, I have a customer now. But the important thing is that all of my queries here in my monolith, I still using my customer DTO query. I should be removing the code that allows me to change the customer from my monolith here, because I'm only allowed to perform in that on my microservice for now. And you can see I just copied the classes, and since I had a proper bounded context, it should be performing well. From my system, I could even say the links from my application could still keep working if I just forward that properly to the endpoint. If I had like if I had implemented like single sign-on, I could with centralized authentication, I could take the benefit of not having to log back and again. If I had a smart router on the front, if I had like a Veritas application or a Zoo application, I just could hide the different endpoints from the side as a same common endpoint. But what I want to show is that the exact query, the monolith, I'm still using the customer DDO, which is a CQRS representation. I was able to move the data to my microservice remote endpoint, and all of my queries are still working here because I didn't even change the structure of the tables that I had in my monolith. But if I just realized that my customer information has a lot of different dependencies, that is too much information, I don't want to be replicating all of this information in my monolith, because in my monolith, all of the aggregation queries that I'm using my read data store, they really don't only use the customer name, the phone number, and something like that. I would only replicate these fields and these relationships from the customer microservice in my monolith. So what do I need to replicate in my CQRS read data store? Just the information that is required for my SQL reporting. Okay? That's an important concept to have. I don't need to keep broadcasting all of these messages from all of the different endpoints. Another discussion that I want to have with you right now, we just realized that with proper bounded context, creating a microservice, broadcasting a message, storing here for reading purpose is something that can be achieved. As I said, it's simple. Yeah? It can be difficult depending on how your information is structured, because we might have to change and refactor a lot your monolith to be able to extract that. But that's a procedure of wash, rinse, and repeat every time. But after you've been able to do that, you can see, again, it's simple, but it's difficult for you to achieve. You realize that I'm not restricted to just creating CQRS read data stores in remote endpoints. It would be your first step, monolith, microservice, read data store. Then you start thinking, if I'm using a CQRS read data store in my monolith, and I didn't need to change all of the queries that I've created before because my tables are still there, what prevents me from doing the exactly same thing even in my microservice, right? So if we were able to change all of our queries here from my code, here I mean the microservice, if all of the queries that I perform, if I'm not returning the entity by itself, not the domain model, not the right data model, if I'm able to refactor or restructure all of the queries that I have to use DDOs which are read data models, which are CQRS read data models. If I'm able to perform this kind of refactoring, then I'm not constrained to storing my canonical source of information as a single row with lots of columns inside my database and my relationships. I could even be changing my write data model inside my microservice to an event store, right? Which kind of event should I be creating? Just like the ones, sorry, just like the ones that I just created here using this customer notification service. I could create very low level event sourcing events saying, well, I'm saving a new customer, or I'm updating a new customer, I'm deleting a new customer. And you could perform this kind of things if you just add here your customer table. You're not restricted to just having a customer representation anymore. You could even refactor that. You could say that it's not a customer anymore. You could be creating something like a customer events. And you're just reusing all of the information and structure that you already have. Then the ID would be the ID of the events. You could be using another strategy for generating your customer ID class, just for example, creating like, as I've talked to some people here before too, it's a nice way for you for your customer, instead of just using the plain old ID generator from the database, creating a business key to identify any of your identities. So you could be creating like, I don't know, a business key or something like that. Then you're just creating a customer saying, well, now I'm creating, and you could create a customer event type, which is a customer created. You store that in your database. Customer updated. You store that in your database. Customer deleted. You store that in your database. So the customer is not just a simple column, row and column, I have the customer information. This would be an event store, because instead of writing customer entities, you would be writing customer events. And you could even take the benefit of reusing the current customer restructure for that. Okay? If you read some books about event sourcing and CQRS architecture, some people advocate for, now that if you want to create an event store, some people even advocate, well, we could be serializing this payload as plain Java objects using object serialization, which I don't recommend, because you know that enterprise information systems, usually you have to hold this information for decades. And you don't want to store legacy Java serialized objects, because the structure changes over time, the fields change over time, and the types change over time. You don't want to be doing that. A better approach maybe would be to have like an event store type, where you could write some JSON format. Some people advocate for MongoDB, because it's already JSON, you can write that. Some people also would say that MongoDB maybe is not as reliable as you would think for this kind of thing. Okay, I still think, again, that for enterprise systems, it's much easier for you to keep using your relational database to be storing your customer change events. Because since we have like advanced reporting requirements for that, and we're already using CQRS read data models in our microservice, like the customer DTO to perform our queries, we could just plainly and simple store our customer events as another table. I just renamed the table from customer to customer event, add some fields, make them immutable, because an event, you never change that anymore, and you start to propagate this kind of customer events to your different endpoints in your system. I truly believe that this is the easiest way for you to achieve an event sourcing architecture with distributed CQRS read data store, which were the original purpose of CQRS read data stores, right? As I repeat again, when Greg Young coined the CQRS term, it was supposed to be a step towards event source systems. This is the step that he wanted to perform to achieving event storming, People didn't realize that at the moment, but now that we know that we can use for that, and the message brokers are very popular these days for distributed systems, you just need to change in refactor your system to be storing these events, and you'll be calling, instead of a customer repository, customer event store or something like that, and saving. Benefits of using event sourcing means that you have an audit log for free, but some people don't like to call event sourcing as an audit log because audit log has a bad connotation because you usually don't have all the information. If you're using this kind of event store, you always have all the information. You have a free time machine. You know when the information was changed. If you add some security context here, you know which user changed the information here. You know which was the previous value. You can perform a free time machine. You want to know which was the customer data on this date of the year, on this time of the day, in this specific moment in the past. You get all of these things for free. And why should I do that? If there are tools like Hibernate Inverse, which could be providing me this auditing also for free. Hibernate Inverse won't integrate this beautifully, this nicely in your microservice architecture for broadcasting your event changes. Okay, so that's some of the considerations that I want to show to you. I could use some of the time. I still have some minutes left. I could go back to my monolith and create if I go here to my monolith, the end goal for me would be to show you how to create an order DTO using the order controller. But since I want to show you another feature, another tip that I have for you when you have to perform queries and you want to do that using like if statements in your code. So I want to take like this very few minutes that I have left to show you how the customer controller is implemented. You can see the form class is the one that holds the information that I'm having this form that has a name and a surname for a query. Since the things that I'm typing here, they don't have to be full. They don't have to be full names because I can type just part of that. It can be types. I can ignore the case and the queries. Nothing else. I can type this kind of things too. How do I perform the things and just keep my business logic very small here on the. In fact, I can do that in the microservice too. Just exit here. Microservice presentation. How do I achieve that? Why is complaining? Customer DTO. Where's my? Oh, here. Type it on the wrong screen, sorry. Customer repository. Customer. Here in my microservice. Monolith, wrong project again. Okay. Is it full screen? Microservice. Okay. Microservice. Oh. Customer. Perfect. That's working. If I open here again my customer controller, You can see the customer form holds the queries for my entity. And you can see I didn't type simply string and something, because if I did that, string, and I would have initialized that as null, I would have to type, well, I'm creating a predicate. This is specific for queried SL, but you might see that I would create a string builder. And traditional way for me to be creating these JPA queries would be so that, well, if name is not null, maybe I can then append like where, like I'm from customer, where c.name, like, and I could be using something like that. I could be appending. So basically the logic would be, I would be always checking if the argument is different than null, then I would append to the thing, to my builder. So later I could create like a builder to string and append that to my JPA query. The bad things about that is I have to first always be checking if it's different than null, if the value is something that I want. If I wanted to have to perform a like query in the beginning and in the end of the things too, I would have to add this logic when adding my text for the query. If I want to check, if I wanted to ignore white spaces on my query too, I would need to be checking here if different than null, if name that contains like a white space, maybe I would have to trim or not trim or add this kind of things. And this kind of logic gets scattered across all of the controllers, a lot of the queries that I want to perform. Typically for me, this is a use case for applying what we call a null object pattern to solve this kind of problem. So, and you even need the special case that if you don't type anything on the name and on the surname, you don't want a where clause, so you don't want to append anything. So these are the logics that you need to control when you're just playing with the if statement and everything else. That's why I created these classes, single string arguments, which are basically factory implementations. That provides you, if you provide a null value or an empty string to the single string argument, it will return for you a null object, which will perform absolutely nothing when you execute this kind of method, which is customer form. So what do I do here? Name is the object that I have. I have append methods. If you want to have a null object in your system, you always need to ask the null object to perform some kind of action. So I ask this single string argument, which is a class with two different implementations underneath it, to get the builder to append the where clause or the like clause on this particular field of my JPA entity. And if the user typed a null name, the thing that is getting injected here through the faces converter is a null object. If the user typed like a string, the thing that is getting injected here through the faces converter is the instance that has some implementation. And I even provided some nice implementations because a customer once required me, because he wanted to perform some queries like that. I want, and which is available in other systems too. I want to, I have a query, but I want all the names A dash to E, and then continue with this one, or A to L, A to F, and start to D, S, O, N. So you can perform like you can instantiate different implementations of this class, single or could be interface too, of custom or single string arguments, depending on what you want as an argument. So I have this code available on Maven Central as a library, just for you to check that. So the source code is available on my GitHub too. There's a nice implementation of null object pattern because you don't need to worry anymore if that's null, if that's not. And depending on the kind of argument that you have here, you have a different implementation of a query that you can apply. So if you want a range, here I have a single string or argument. You just type, if you want a single, if you want a range string argument, you can apply queries using this kind of range. If you have an integer argument, a single integer argument just accepts integers. If you have a range integer argument, you can just type from 1 to 10, and it's going to return for you in your query. So it can perform nice things in your query.sl query just by using like the factory methods, null objects, and different implementations from each one of these cases. Okay. And that's most of the things that I wanted to show today. Again, I had a lot of things in my mind, and I'm sorry if I didn't explain all of the concepts that I wanted or the concepts that you wanted to. But as I said, it's much clearer when you're reading something. That's why I'm taking some time to write a book and try to explain all of these techniques and much more techniques. And I hope you have been able to enjoy and learn something from this talk. It was supposed to come from the very beginning to show some integration purposes. I hope that I have achieved some success trying to show to you what is a CQRS architecture, how you can use that to solve performance problems, integration problems, and how can you use that step to achieve some sort of event sourcing in microservices architectures. Okay, that's what I had to show now, and thank you very much.